Welcome to Lesson 2, Translations. A translation is just a transformation, as you learned in the last video. It's one of the many types of transformations that can be done to an object. Our objectives are to name images and corresponding parts, to use a translation vector to find the coordinates of an image plane, and to write a rule to describe a translation. Down here I have some examples of different translations. We have a star here, and as you can see, all we have done is slid the star to a new location, and that is basically what a translation is. We are going to be doing this on the coordinate plane, so we're going to have coordinates for each vertice, each point of our object. And when we look at the coordinates, when we translate, we take the coordinates and we add or subtract x values and y values in order to slide our original shape to a new location. That new shape is called an image. It's an image of our original shape. Over here, the translation has been described as this figure slides 7 units to the left and 3 units down. Here is our original unit, and we slid 7 to the left and then 3 down to get our image of our original shape. Let's look at how we can name images and corresponding parts. How do we know which shape was our original image or our original shape and which shape is the image that came from the original shape? Well, the way you know is because of how it's labeled. In this first example, you'll notice that we have two A's, but the bottom A has an apostrophe by it. Same thing with the B and the C. Well, this is read as A prime, B prime, C prime. And anytime you have an apostrophe, that means it's an image of the original shape. So we took A, B, and C, we translated it, we slid it down, and now the blue triangle is our image. Let's look at that with this other triangle here. So we have A, B, and C, and this looks like an equilateral triangle, which means that all the angles, all the sides are the same. If I take this triangle and I move it around, it still is an equilateral triangle. It doesn't change. So our image, when we translate something, is congruent to our original shape. It doesn't change. Notice that when we do a translation, I did not flip this, reflect it, rotate it, or change the size. That's how we know it's a translation. We just take the original image and we slide it somewhere else on the coordinate plane. So let's go ahead and name our new image. One thing that's important, as I mentioned before, this is probably an equilateral triangle, so it probably doesn't matter what angle I name A or B or C or what vertex, because it's all the same. However, we need to make sure that we keep corresponding angles aligned. So as we remember, this shape, if we duplicated it and we slid it, then our A has to be here. And this we would call A prime, remember, because it's an image. Our B would be up here, and that would be B prime, and then our C would be down here. So it's very important to keep corresponding parts, corresponding angles, corresponding vertices labeled the same. Let's look at an example now where we're going to use a translation vector, it's called, to transform an object. Under a translation, every point is moved by the same amount in the same direction. It's just a slide. In this first example, we have moved everything 2 units to the right and 4 units up. So this vertex B went 2 right, 4 up. The vertex C went 2 right, 4 up, and the vertex A went 2 right and 4 up to get our image up here, our new location. Translations and vectors. The translation at the left shows a vector translating the top triangle, so our purple triangle is the top triangle, 4 units to the right and 9 units down to get the blue triangle. The way we write that movement is in a vector form, like this, 4, 9, with these symbols on the outside, different than parentheses. So in order to translate this first shape, we use this translation vector 4, 9. This corresponds to our x and y coordinates. 4 corresponds to x and negative 9 corresponds to y. So it is very similar. It's just that this tells us how much movement we need from our x and how much movement we need from the y. When I look at the 4, it says we need to go in the positive direction 4 spots. And for the y, we need to go in the negative direction 9 spots or 9 units. If we take, for example, this point here, we'll call this A from our original shape. We take the coordinates, which are negative 6, comma 1. Those are the original coordinates. And we would add 4 to the negative 6. If we add 4 to the negative 6, we should get negative 2. So our new x-coordinate should be negative 2. To our y, we're going to subtract 9. 1 minus 9 is negative 8. And if you'll notice, the coordinates of our A prime, of our image, are in fact negative 2, negative 8. Another way to notate vector movement is by using a matrix. So you can see that x is on top and y is on bottom. But it's going to be important for you to remember that this is not a point, this is a movement. This is a movement to the original shape to create the image. All right, let's look at an example. Let's translate this image, or it's not an image yet. Let's translate this original object by negative 2, 6. So this is our vector. This is our translation vector. Go ahead and pause the video and try to come up with the new coordinates of the translated object. Okay, there's two ways you could have done this. You could have taken each vertice and you could have slid it to the left 2 and slid it up 6 to arrive at its new location. So for example, with A, we could have gone over 1, 2, and then gone up 1, 2, 3, 4, 5, 6, and made a point, and called that A prime. And we could have done that for each of these. And then we could have connected the dots. That's one way. Another way we can do that is to actually write out the coordinates of our original image. So if we write out all the coordinates, for A we get negative 2, negative 7. So what I'm going to do is go ahead and write out all these coordinates. Once I have all the coordinates written out, I'm going to apply my translation vector of negative 2, 6 to everything. So that means I'm going to add a negative 2 and a 6 to every x and y coordinate that I have written out to get my new coordinates. Now when I add these all together, I will come up with the new coordinates of my image. Negative 2 plus negative 2 is negative 4. Negative 7 plus 1 is negative 1. And then over here we have 2 plus negative 2, which is 0. And negative 6 plus 6 is also 0. And then we have 0 again, 3, negative 4, and 4. So these are our primes, right? These are our coordinates for our image. So this first one we know is A prime, and we've already marked this one as negative 4, negative 1 right there. This is our B prime, and we can go ahead and mark that one as 0, 0 right here, and this is our B prime. Make this a little more visible. And then we have 0, 3, which is our C prime, and negative 4, 4, which is our D prime. So again, important to keep these corresponding. That way we don't confuse them. Now all I had left to do was connect the dots, and I have my new trapezoid, my image. And it's that simple. Our original shape was translated to the left 2 and up 6 to get our image. All right, one more test. See if you can determine which vector translated this blue image to the red image, or I should say the original shape, the blue object, to the red shape, which is now our image. So which of these vectors has done that? Go ahead and pause the video and see if you can determine the answer. Okay, well hopefully you've come back with B. And the way to tell is to take one of the vertices. So we'll go ahead and take this vertice here, and let's count. We went from here to here. So how far over did we go in the x-axis? We went 1, 2, 3, 4, 5 in the positive direction, and then we went down 2 for y in the negative direction, and that is B. All right, our last task today is to be able to write a rule to describe a translation, which is basically just what we did. So let's look back at these original shapes we had looked at before. What is the rule to translate our original object to the reflected image? Well, let's count. So for A, we went over 1, 2, 3, 4 spots, and then we went down 1, 2, 3, 4, 5, 6, 7, 8, 9. So we went to the right 4 in the positive direction, we went down 9. Let's look at these two images. We are going to translate ABC, triangle ABC, over here to this orange triangle, and that will be our image. So what translation vector would we need to do that? Well, remember, it's not rotated, so this we can be assured is our B prime, and this is our A prime, and this is our C prime. So how did we move from blue to orange? Well, for A, it looks like all we did is move over 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So we went to the left 9. We did not go up and we did not go down. So we did not have a translation on the y-axis. So our translation vector is -9, 0. And that concludes our lesson on translations. So hopefully now you feel comfortable naming images and naming corresponding parts. Also using a translation vector to find the coordinates of an image in a coordinate plane. And you can write a rule to describe a translation.